Well, let's fast forward about 4 months and we got a lot of talking to do. So let's get started. Hey everyone, thanks for checking back. Today we're working on Wall-E's arms, fingers, wrists, shoulders, you name it. We're gonna try to tackle that in this video. It may be a little longer. And the reason why it took a little bit longer for this video to come out, to be honest with you, is we were running into part failures. And specifically with the wrist part here. This was originally designed to be a one piece with the detail part here of his top of his wrist, and you can see that it's missing. It broke off. Accidentally, I tipped this off the table and it just broke. So we took a look at the layer lines. It seemed like they weren't bonding or fusing very well. We raised the temperature 10, 15 degrees, and lo and behold, we did some more drop tests, and it took a little bit more drops for it to break. So with that in mind, we do a redesign. We figure out where the problem is. So on this particular one, I believe we solved it. So now we have 3 separate parts. This orange one at the bottom, and then these 2 right here. So now they're in a favorable position. So this prints sideways, so flat on the bed, layer lines are better. And the same thing with this small part. They are then bolted together, inserted into a shallow pocket, and then bolted here. So now it's clamped in a lot of directions. We did a bunch of drop tests and this held up perfectly. Cannot complain. So following this up, we have a nylon part here. I believe this is PA6 glass fiber on these 3, as well as this orange part. That is a glass fiber nylon from bamboo. And to continue the story, we took these parts to 3D Experience World in Houston, where we then, myself and Seth Kelly, brought Wall-E, and we just shared the project with them. One of the manufacturers we met there is Michael from A3D Manufacturing, and he took an interest in the Wall-E project and thought, hey, we want to help these guys out. So we showed them the issues we had with our risk, and we came up with a strategy of combining these 3 parts into one. So now it's a solid piece, as well as the front parts here. So those 2 parts were combined with all of the engineering installed, and the back piece as well with the heat sets. So I want to thank Michael from A3D Manufacturing, and to learn more about them, you can go to a3dmfg.com, and they do have real-time pricing, so check them out. This is not a sponsored video. We were just totally happy and excited for them to help us out with this. So let's talk about what we're gonna do here. We're gonna do some prep work. We're gonna talk about some subsystems separately, the thumbs, the fingers, the servos, the forearm, and how it goes together. So what I wanna touch base on first is the forearm and what had changed, what's the same, and what we're gonna do there. So here we have our forearm part. Basically, this is the same part that we provided to the club for the motion arm system, with the addition of this insert with a brass bushing instead of a bearing. What's left to put on here is a couple magnets. The parts that go and install in here are the chassis here that rotates the wrist, as well as this servo with its plate. This pockets in, slides back, and then engages on a gear that rotates about the shoulder part. And we'll get into that one a little bit later. The next prepping part we're gonna do is we're gonna take these MJF parts, we're gonna clean up a little bit of material and prep them for assembly, adding in the nuts and bolts. We're gonna swing into the thumb and finger and install them. So let's get to work. So a bit of prep work went into some of these parts. You can see I had sanded these down. They have some slip rings that support them in the forearm. So I thought I would just put those in and show you how that works. So we'll slide that one all the way in. And then this one sits in on the inside like that. And then as the arm or the wrist inserts, it rotates about in that fashion. So it's nice and smooth. I don't feel much resistance at all. So next what we're gonna do is I'll slip these out. I'm gonna prep the next part, probably end up doing the same thing. We're going to see about mounting the 2 servos and the center servo as well, and see how those fit together. So we were able to mount the servos, get all the screws in place, all the wires tucked in their little channels, and I'm happy how it turns out. You can see how that navigates that location there, as well as this one here, and the thumb here too as well. So the next step is to put the fingers on. Now granted, mechanically this is set. The fingers are actually, in my opinion, just decorative now. So these are just magnetic covers. So they just slide right on. There's one, and there's 2. I like that they're modular that way. So if you needed to swap the servo, you can access it pretty easily. You can see the magnets in there. So with the thumb cover, and that's exactly what it is. It's a cover. It has the channels built in for the servo. It also has a area for clamping it on. So you slide it over, 2 screws into some heat sets, and it has a clamping force to hold it down. So what I need to do now is just build the half of the thumb here, just some heat set screws and some glue. We'll get this mounted and we'll see one of them all together, and then we'll build the second one and see how they install in the forearm. So we have our thumb put together. You can see it's fastened with the 2 screws. All the parts here are glued and screwed together. I even slipped the pin in and have it just temporarily so we can see how everything folds together. And it's looking pretty good. All the servos are now working independently, driving each joint. So next steps, we're gonna build the second one and then fit it into the forearm, meaning we're going to take our forearm piece, make sure our IGUS bearings are in place. I do have to hot glue or CA glue this one in. It is a little bit loose, it's not as press fit. We'll slide it in, make sure it engages with the servo block here, and we'll show that. And hopefully after that, we can then pivot to the shoulder piece, install that, and then redo everything, put the cap on, add a few magnets, and I think from that point we will have one finished arm. So let's get started. And for those of y'all interested, these are the Reef 179 micro and 55 micro. So you'll have one of these on each finger, and the 55 will be for the thumb. All right, so I installed the servo block here that rotates the wrist. I've tucked the wires in, and let's see just how well that aligns up. And it pops right in, we like that. So I can go ahead, rotate this. Feels pretty good. So now that I know that's gonna work out well, I'm gonna go ahead and remove this here. I'm gonna glue that in. We're going to install the shoulder part with its axle and its outside bits as well. Install the servo motor that pivots off of that shoulder gear, and then simply replace this part. We have a tensioning screw that'll apply tension to the servo gear so the mesh is nice and tight. We'll reinstall the arm, tighten the clamp that is on the back side there, and we should be able to have a fully assembled arm minus the cover that we can then test. All right, let's get going. Okay, let's install the shoulder part. And we're simply gonna take our PTFE washers and we're gonna line them in the little slots that they fit into, top and bottom. Hold the top one and then slide our shoulder part assembly in place. If it slides, make sure you slide it back in. And then we have our axle with our cap. And if this is the top of the arm, as you're looking on it, make sure that this doesn't have the set screw on that. So we'll see if we can align this pop it right in. First shot, doesn't always happen that way. So we'll go ahead and spin this on a little bit. Grab the right Allen wrench. And since we're just doing this temporarily, we're just gonna keep it a little loose. And there you have it. So now we'll go ahead and install the servo that then pivots off of that, the servo for the wrist, install it, and we'll take a look at what that looks like when it's complete. So now we have the arm pretty much fully assembled. We don't have the cover on here, but we can test out the compliance of it all. So making sure things rotate as they should freely. We can rotate our wrist. I don't feel any binding. And then we've already moved the fingers around, so that seems to be working pretty good. Overall, happy how this came together. So now I'm gonna take it all apart. I'm gonna put the magnets in and then install the cover, and then let's put it on the chassis and see how the arms fit. So before we actually test the installation, I went ahead and installed the magnets on the door and the arm, and also pre-wired it. So let's just take a look at that. So let's pull this off. And what we have in here is a PCB that links 4 channels. A previous model, we only used 4 servos in here. I have this extra line coming in for the 5th channel. And then we ran our cabling through. So if I hold the arm here and rotate, typically in the bay here, everything just moves around. When you have it kind of pushed in there and the cover on, it all just stays in one place, which is really neat. All right, so let's go ahead and see if we can put this cover back on in one go. There it is. Sometimes you have to kind of tuck the wire in a little bit. So let's go ahead and readjust our camera here, and we'll see this going into the arm. We're gonna try to tuck these wires in at the same time. Once we see that going in and we like that, we'll address how we're gonna plug this in. So what we're gonna do now is show you how we install the arm. We don't have our plugs on yet, but that's okay. You have 2 locations. You go above the linear actuator and then down, or you can tuck down the side here, depending on your plugs. So for the sake of this example, we're just going to feed them down below and show you how that goes in. So right now, the length is long, which is great. So that way, when you're going to design your wiring, you're not too short. So we'll go ahead and then line this in place. We need a little bit more slack. There we go. And once you hear that sound, it's just dead ending on the back, and then you would tighten your clamps here too. So now you can access your arm, you can open it up, get into whatever you need. You can test some of the movements. So what are we gonna do next? We're going to remove this, make sure our fingers work again. If there's any magnets we have to add to the fingers, and then decide whether or not we need to add additional length to our wiring. I don't think so. And we will get closer and closer to having this actually tested. So let's see what that takes. So with Wall-E here, we've been through a lot, and I've designed control system and power system and sound system. I went ahead and installed all the pre-programmed sequences that I have, which is only 4 at the moment. And Wall-E here is now wired up for drive as well as performance. So I don't know where to get started, so we're just gonna start somewhere by turning him on and showing you what he can do right now and how it took to get there. So I said we're gonna see him turn on, but let's take a look at some of the systems that I went ahead and designed for him. So in the back there, or towards this front, we have the control, we have the programming, and we have our amp here too as well. This is a 2-battery system, so one drives the system, one drives the speed controllers for the drive system. They are already hooked up. Each one has its own solid state relay and fused out. We have 3 buck converters that drive each individual system, 2 for servos, 1 for linear actuator. And the last system in here, which you don't see, is the linear actuator that drives the body tilt. And just kind of give you guys a little bit of a view there. So really happy how that turned out. I think later on we can do a double stack of batteries, just as Seth Kelly did, and that'll pretty much double the runtime of what we have. So I just have a speaker here hooked up temporarily so we can hear the sounds play as well. So let's turn Wall-E around here to the front, and we'll just show a little bit of what the arms can do currently and talk about what I want to do in the future. All right, let's go ahead and enable Wall-E's body, and we'll turn him on. And you'll see his head come up to center because it follows where the servo centers are versus the sticks on the transmitter. It takes about a second or two for it to come alive. Let's check it. There we go. So we know he's on, and we'll just do a quick systems check. And we'll lean his head left and right, up and down. So there we go. So we know that the arms are on, so let's go ahead and do one of the simple sequences. This is ta-da. There we go. So swinging the arms out, turning the wrist, hands go out. Pretty much everyone loves that. So, and the only other two I have so far are what I wanted to do in the first place. I want to do some fist bumps. So we come up, we give him a little fist bump, a little high five, spin him straight again. And then we can go ahead and bring him back to center. We can also do that with the right. Right will come up. We can give him his little fist bump and come on down. One variant I want to do with that is the hands up, so we can do a high five and then the same closure as it comes down. One of the pass-throughs I have on here are the finger gestures, so I can twitch the fingers a little bit. And I also can do that while the arm is up, so we can do a little wave, goodbye. So that's fun. And then the hand returns back down again. So that's all I have done for sequences now. I'd love to do more, and I plan to do more once Wall-E is finished here. And I'm gonna show you guys one last system here before we finish up this video, and that is the crossbar and the pivot point on what that goes on to. So in the end, I like to do some more pre-programmed sequences, but for now, we're just gonna go ahead and move it. I know folks wanted to see if the servos make any noise, and they do, but for here, we prefer the smoothing over that, because in a loud environment, you don't hear this, specifically at cons or schools, hospitals, things like that. The sound gets drowned out. This is all done through Kyber smoothing, so we're pretty happy how this turned out. There we go. See his little fingers, do a little dance for you. Do a little fist bump, and then he'll come back down and wave. And real quick, I want to show y'all some of the testing we did for the arms that are for pass-throughs and not through Maestro. And I'm pretty excited to see some of the potential movement this thing can do. So check this out, and we'll hope you like it. All right, this is a cool little move. Like I was just messing with the arm and just saying, hey, come here, kid. That's neat. It just literally it's just twisting and pulling the fingers in. Come here, come here, come here. Or it could be like, nope, 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 nope. Or, yeah, that's a little good one. Like, hello. That's cool. Neat. Here's another view of that. Kind of looks natural a little bit, like. Cool. So here we have the crossbar that Wall-E's mainframe mounts to, and this is the pivot point that the chassis is on. This is where the receiving end of the tracks would go for the left and right. And then here's the pivot point here that I just need to get welded on. And what happens is this is our fixed point. So when we have our linear actuator, this is what it pivots off of, either tilting the body forward or back. And if we take a look in here, you'll see the other part where the 32 millimeter dowel will sit in one side and will sit in the other. The linear actuator mounts to the top here and to that crossbar. And when it extends, the chassis pushes forward, and when it retracts, it pushes back. There's also 2 gas shocks on here to take some of the bounce out of it as well, to dampen that. Because sometimes these linear actuators have a bit of play in it. So let's talk one last thing before we head out, and we'll go there. So guys, I just want to close this thing out with me and Wall-E. Thank you guys for watching the build here. This is the last one I'm going to make for this series here. So look for finished pictures of him when he's done. And hopefully we inspired everyone to make their own Wall-E and live the dream. All right, we'll see you guys later.